Think about this for a second. An AI-powered robot moving with unbelievable speed in a factory. But what happens in that tiny, split second before it makes a huge, catastrophic mistake? What's the failsafe? Well, today, we're going to dive into a new layer of safety that's designed to be exactly that, the final guardian.
This sentence, it just nails the whole concept. Look, the idea isn't to replace the AI that's driving the robot's brain. Not at all. It's all about adding a crucial checkpoint, a gatekeeper, if you will, that gets the final word before any command becomes a physical action.
So why is this such a big deal? Well, when you let an AI control heavy machinery in the real world, the stakes are just sky high. And the problem, up until now, is that there hasn't been a standard way to double-check the AI's decision before it happens. It's a massive and, honestly, a kind of scary blind spot.
And this slide just lays it out perfectly. I mean, if an AI serves you a bad ad online, who cares? It's annoying, maybe, but that's it. But if an AI tells a multi-ton industrial robot to smash into something, you're talking about catastrophic failure. Millions in damages, production lines down, or way, way worse. The consequences aren't even in the same universe.
So you can see, right, this missing layer creates some absolutely massive risks. Without any way to validate that an action is safe before it happens, companies are just totally exposed. We're talking huge regulatory fines and the kind of liability that keeps CEOs up at night.
Okay, so what's the fix? This is where the ARTANI Gate comes into the picture. The best way to think about it is as a new blueprint, a whole new reference architecture for safety. It's this simple, really elegant solution that acts as a gatekeeper between the AI's command and the robot's action.
The term you absolutely need to remember here is pre-execution validation. We're not talking about figuring out what went wrong after an accident. This is all about catching a bad idea, a bad command, before it ever gets a chance to cause any harm. That little word, before, changes everything.
You know, the process itself is beautifully simple and logical. It's a four-step dance. Step 1, input. The system gets the data on what the robot wants to do. Step 2, validate. It checks that data against a trusted system that knows what safe looks like. Step 3, decide. It makes a simple go or no-go call, allow or block. And step 4, audit. It records that decision forever. Input, validate, decide, audit. That's it.
All right, enough theory. Let's see this thing in action, because that's where it gets really cool. We're going to follow a day in the life of a single industrial robot. Let's call him Atlas 01, and see what happens when it gets two very, very different commands. Everything kicks off right here, a data intake. The system is getting a direct feed from the factory floor. It's looking at structure data, like motion vectors, which is basically just where the robot's going and how fast, and something called volatility, which is a fancy way of asking, is this movement smooth or is it getting a little wild? This is the raw data for the safety check.
Okay, so the first test for Atlas 01 is about as routine as it gets, a normal pick-and-place task. It's the kind of thing this robot probably does 1,000 times a day without breaking a sweat. This is our baseline for what a safe, normal action looks like.
And, no surprise here, ARTANI Gate gives it an immediate, clean pass. You can see the risk score is a super low 0.484, way down in the safe zone. And the reason is simple. The motion is stable, it's predictable, it's exactly what it's supposed to be. So the gate swings open, and Atlas 01 gets the green light. All right, now for the fun part. The AI sends a totally different command. This time, it's a high-speed motion, something that could be unstable, erratic, maybe even dangerous. This is the moment of truth for our safety gate.
Whoa, and there it is. This is the money shot, right here. Instantly, the interface just flashes a massive, unavoidable red fail. And the action? It's crystal clear. Execution is blocked. That dangerous command is stopped dead in its tracks before the robot's arm can even twitch.
So why did it fail? What was the red flag? Well, let's zoom in on this one number. The volatility score for that proposed move was 0.90. The system has a hard, non-negotiable safety limit of 0.55. So this command wasn't just a little bit over the line, it blew right past it. It's an instant, automatic nope.
And this is where it all comes together. The decision ledger. It's a permanent record of everything Atlas 01 does. You can see the calm green line of all its normal, safe operations, and then, bam, there it is, that sharp red spike.
That is the exact moment the system caught the dangerous command and shut it down, creating a perfect, unchangeable audit trail. Okay, so we've geeked out on the tech, we've seen it work, but let's talk business for a second. Because a system like this, it's about more than just technology. It's about building an architecture of trust. It's about creating something that's legally defensible.
So what makes this so special, so hard to copy? What's this defensible moat? Well, first, there's a non-replicable reference system for validating behavior. Good luck trying to copy that. Second, it's backed by a really extensive patent portfolio that's growing all the time. And third, and this is key, it's not just some piece of software you install. It gets integrated at the architecture level, baked right in as a core safety layer. It's really hard to replace.
And what does this all mean for a business? It's pretty simple. You get a permanent, ISO-ready safety record for every single action your machines take. This is how you prove you're compliant. This is how you manage risk. And this is your shield against crippling liability. So I want to leave you with this one big question to chew on. As our machines get smarter, as they start to think and act all on their own, in our factories, on our roads, even in our hospitals, how are we going to prove that we can trust them? Because having the ability to check their homework before they act, that's not just going to be a feature, it's going to be the absolute foundation of trust. Something to think about.